Well, thanks to the Sin University administration, Vice Chancellor, and other definitely talented team with him, which make it possible to create alternate for our students as education is so much important. So this live session will create other opportunities as well. So I'm with you. Try to make it easy for you students. You all of you welcome again. My name is Mohammed HUSSAIN and the subject assigned to me is linear algebra. So we are going to start. So with the name of Allah, who is the most beneficent, the most merciful, who will make it easy for us and end it with happiness, inshallah. So the next slide will be, so this course was divided in 46 lectures, assigned 2 exams, okay. So grading was, the 30 marks for the midterm and the final exam 50 marks. With that assignment performance marks is equal to 5 and the last attendance equal to 10 marks. But as for this case, due to the coronavirus, okay, and marks are now midterm and the plus assignments equal to the 40 marks and remaining will not yet decided. So hopefully when it comes in the meeting, in the finalized session, then we will surely get the notification. So these are the reference book which I already referred you, okay. So hopefully you all have the PDF of it. Brought a linear algebra book, as you know that, which author name is Muhammad HUSSAIN, which I know that you all bought that book. The content of linear algebra, so these contents, and we have much covered our course and hopefully we will make it complete as soon. And row matrix and the rank of a matrix, Gaussian matrix and Jordan matrix and echelon and so on, and also the application of a system linear equations. So now we will start our session, but before it we have to remember that we have completed type of matrix. Surely you will get my videos on this topic which we have covered on YouTube. I will try to make videos of each lecture so you can get it on YouTube. Application of system linear equation we have covered, like if you have remembered that a zoo charges $6 for adult and $3 for the student and $4 for the children. So we have made 3 equations. The row operation will perform 2 plus 2 will become 4, okay, and it assigned to this a variable. 4 is a unique number now for the a variable. We do something with this matrix, this square matrix, and we will get a unique number. So here a will get a unique number. How it possible? We go for the definition first, that the determinant is a unique number associated with a square matrix. So for this square matrix, and we will do some operation on this element. So in the end result we will get a unique number. What is the determinant of matrix A? What is the determinant of matrix A? Or we can ask this question in another way, that find the value of A. You can see this vertical bars which represent determinant, as you call this as a symbol of a determinant. Okay. We have to see the diagonals. This is the left diagonal, okay. So where you can observe 5 and 6 element, okay. So one thing we get right now from the left diagonal is that 5 and 6 element, and we have another diagonal as well, and which is 1 and 2. So now we have 2 diagonals. So finding the determinant of 2 by 2 matrix, you have the first 5 multiplied by 6, you can say 5 and 6, you write it down in here, 5 and 6, okay. And then the technique is that after the 5 and 6, after the writing the first term, you have to write minus sign, okay, and then another diagonal you have to write it down, so which is 1 n, okay. 5 multiplied by 6 become 30, and then 2 multiplied by 1 become 2, and then furthermore if you subtract 2 from the 30, then you will get the 20. So it's in the wording format. So you will read it and find out the value of this matrix, actually means the determinant of the matrix. Write the answer of it, okay, in comments. So it will be appreciated when really you can do it for me. Thank you. So this is question 1 and similar as question 2, okay. Try it again. Try to give me the answer, and question 3, okay. I gave you the question 3 up to the 4, okay. So this is question 3, write it down, try to make it as soon as possible. I will wait for your comments. This is question 4 regarding with the 2 by 2 matrix. Try to solve it So what is the determinant of 2 by 2? Left horizontal or diagonal. So this is a diagonal actually, okay, A1 and A5. Write it down in here, and the technique is that after you have to write minus sign, and then another diagonal, choose another diagonal which is A2 and A4, write it down in here and solve it accordingly. Now this matrix is not 2 by 2, its matrix is 3 by 3. Can we do the same technique with this matrix? So if we try to solve this determinant, how we do it? We have the left corner diagonal, okay, and right diagonal as well. But what about the others remaining elements? So it's very difficult to solve it, okay. So now we are going for another technique, that is simple, write it down A1, where the A1 lies, you know, where A1 existed, where A1 exists, just hide that row and column, hide where A1 lies. So you will see this A1 lies in here, okay. So you have to hide this whole column as well as the whole row. You will observe elements remaining. The remaining elements are like A5, A6, A8 and A9. So now if you remember, this is showing, giving the observation of 2 by 2 matrix which we have covered. So what will be the answer of that? And I think you have remembered that 2 by 2 matrix, okay. Write down now A5, A9, minus sign, and then A6 and A8. Simple as that, okay. Now, so this is the one term. If you remember this, after the one term you go for the minus sign. Okay, so what is the determinant of the matrix A? Okay, can we apply the same technique which we applied for the 2 by 2 matrix? I don't think so here, okay, but we will try for this. Okay, let's suppose what the situation for the 2 by 2 matrix, if you remember, okay. So one thing is that we have to take care of the left diagonal, okay, we can say it left diagonal. This is the, let's suppose the first diagonal we are concerned about, and the second, the right diagonal, okay. But if you think we have left these number of elements, what can we do for that, okay. So we cannot make a diagonal of this A2, A6 and A4, A8. So here for the 3 by 3 matrix we have to use another technique, and that is the A1 element, which the first element of this matrix is, okay, A1, okay, and that element A1 we have to put in here, okay. And then if you observe that where the A lies, you have to hide all that rows and column. So where A1 lies, this is the A1 lies in here in column, so hide that column and as well as the row, okay. Furthermore, if you observe, you have left A5, A6, A8 and A9, okay. So these are now elements are remaining. So if you remember the same concept here, a 2 by 2 matrix, so you can easily find out here, only written by this values like A5 multiplied by A9, okay, and minus sign accordingly, and then A6 multiplied with A8, okay. So now if you observe again, this is our called as the first term, okay. The first term you can set expression, you can set, if you put minus sign, then now so the first term, now then you put the minus sign in here. As we have choose A1, now we have to for the A2. Now we choose A2 for that purpose, and then slowly then this A2 will be written in here, and then the same formula which we applied for the A1, where the A2 lies, we have to hide that column, and where the A2 lies, and with respect to is rows, we are going to hide this column as well and the completely row. So now the elements are left A4, A6, A7, A9. Same concept of the 2 by 2 matrix, now written as in here A4 multiplied by A9 minus, and then A6 multiplied with A7. I think hope you understand this now. Okay, this is the first term, okay, this is the first expression. We put the minus sign in, then we have the second term. So the concept is that first initially you put the minus sign and then plus sign, okay. You can set this as well, this is the plus sign in here, okay, and then minus, then plus, and then minus, then plus, so on. Matrix is more than 3 by 3, okay. After the first term you put the minus sign, after the second term you put the plus sign, and after third term if it is continue, then you have to put as accordingly minus sign. So hope you understand now. So now we choose plus sign in here. Okay, when you go in the practice you can easily understand. In A1, okay, we choose A2. Now we have to point out A3. We write same as this term, and the technique was that where the A3 lies, completely hide the rows and columns where A3 lies. Okay, row column as well as the row. Now the left elements are A4, A5, A7 and A8. Written as A4 multiplied by A8 minus sign accordingly, and then A5 multiplied by A7. So this is the matrix A, and if you want to find out determinant of A, we put the same technique which we used earlier. We will choose the first element of that matrix. So we put in here 4, and we hide the row completely where the 4 lies as well as the column. So now the remaining elements are 2, 5, 2, 3, and you can easily find out 2 by 2 matrix. You can say it accordingly, and that will be 2 multiplied by 3, accordingly minus sign, 5 multiplied by 2. Okay, and as it is our first term, okay, we have to show the minus sign in here, and then 4, now this turn about the 1, put in 1 in here. We have left the 3, 5, 1, 3 element and multiply according. This now is showing the 2 by 2 matrix. So 3 multiplied by 3, minus sign accordingly, 5 multiplied by 1. Okay, so now we are going for the plus sign, just because first expression we get the minus sign, the second expression we change the sign accordingly. See, so it's kind of alternate. So we already choose for 4, 1, and now it's turn about the 2. We ignored column as well as the row. So now the left elements are 3, 2, 1, 2, and accordingly we can solve 2 by 2 matrix which we did earlier. So now 3 multiplied by 2, minus sign, and then 2 multiplied by 1. So now dear students, solve it. I want to know who will do it first. So write down in the comment section. So I will definitely read it down. So students, let's see who will give me the answer first. Write down the comment before you move on the next slide. So try to pause the video here. The answer you will tell me better. So I solved this already. So the answer of determinant is -12. Hope so your answer and mine answer will be matched. Thank you. So now another method to solve the determinant as well we have. So you can find out this page number 70. I'm not discussing here. If you understand this, go for this. Okay, I'm not going for the number of method to solve the determinant. I'm choosing one method. If you think its second method much easier than the first method, go on. So there are two cases for proving this property. Number one, if you have the matrix, let's have A, B and ED, and then find the determinant of that matrix, and you know the 2 by 2 matrix will find easy. So we have A, D minus BE. Okay, simple as that. So one case is that matrix, you can find out determinant of that matrix. Okay, so simple. So we call it case 1. Okay. So now the second case is that again you have the matrix and same matrix, make the transpose of that matrix. Then if you remember how to transpose the matrix, so just convert the row. This is the row, AB is a one row, ED is a second row. So convert the row into the column. Now this row become this column. ED is here is in a row format. Now convert into the column format. You have to write ED in here. Just convert the row into the column. Find the determinant of A transpose. I think you can give me an easily answer of that question. AD minus BE. Okay, so you will find the matrix of as well as, so you find the determinant of A transpose as well. So if you look, this is our case 2. So if you observe case 1 and case 2, the answer are so similar. So here the property said the determinant of A is equal to when you take the transpose of A and then you get the determinant of that A transpose, the result will be the same. So this is the property in 1 and we prove it. And this is the definition of it. If A is a square matrix, then determinant of A is equal to determinant of A transpose. This means the determinant of a square matrix has same value as that of its transpose. Okay, this is the matrix. We get the transpose of it. And here is again a matrix written in here. We get the transpose of it. Okay. And then what is the determinant of it? We got the determinant of it, AD minus BE. If you observe that both are the same, so this property has been proved. So the property number 2 is saying if we have a matrix A but matrix B is obtained by interchanging any two rows of a square matrix A, then that determinant of B matrix equal to the determinant of A matrix. So this is the matrix A, okay, and this is matrix B, but we cannot find the elements of it just because it can be obtained by from this matrix. So how it can be obtained by from this matrix? Because if we write same elements as here, so both will be the same, so there's something will be changed. So how? Just we do interchange the rows, okay, we just interchange the rows of a matrix. What do you mean by the interchange the rows? Here you know that this is the R1, this is the R2. So what we do in here, we just put here R2 in the initial row as this way, CD. In this way R1 are now shifted to this second row of B matrix. So now hope you understand what mean by interchange rows. Now if you observe that A is a matrix and B is obtained by from this matrix by interchanging the rows, okay. Now we find the determinant of both, determinant of A as well as determinant of B. What will happen? If you observe, we will get the AD minus BE, and if determinant of B answer is BE minus AD, and if you observe AD in here is a positive and in AD in here is a negative. Similarly BE is minus in here, in the second positive in here. Okay? So it means that the determinant of B is negative of determinant of A, although determinant of B is obtained by determinant of A. So this is the property said that whenever you take the determinant of B, it will be determinant of A in the negative way only if only we interchange rows. And also we can interchange the column. The definition is divided into two sections, that if we have matrix A but matrix B is obtained by interchanging any two rows of a square matrix of A, okay, and also it's saying that if we have matrix A but matrix C is obtained by interchanging any two column of it, okay. So we can interchange column as well, we can interchange rows as well. Now property 3 is saying that if two rows of a square matrix A are identical means that the elements are same, okay, then the determinant of that matrix will be 0. Okay, let's see, this is a matrix in here. So AB and AB, okay, the both are the same thing. So here is saying that two rows, if we are going for the two rows, we observe that this is a row 1, we observe that this is a row 2, okay. So both are the same, then surely the result will be 0. Now the property number 3 is also adding there the two column as well. If you are saying the two column are the same, then the results will be the 0 as well, okay. So if we are going further, then we are going to solve it. AB in here, if we are taking the determinant of it, AB minus or accordingly, and then again there's a BA, or you can write it AB or same thing. So here is we write AB, so both are the cancel each other and it will become 0. So hence proving that property number 3 as well. We are going for now property number 4. It's saying that if all entries of a row or a column of a square matrix are 0, then the determinant will be 0. So let's observe this. This is a matrix. Here we observe all entries. Here's the row 1 you called it, and here all entries of this row 1 are 0, and it's saying according to definition, when your all entries are 0, the answer will be the 0. If we try to find out the determinant of this, so 0 multiplied by B and minus sign accordingly, and then 0 multiplied by A, we got the answer 0. So it's proving property number 4 as well. Okay, this is for the rows, and now this is for the column. If we are going for the row, all column entries are 0, what will be the answer? Then if we find out determinant of that matrix B, then 0 multiplied by B, it is easy to find because 2 by 2 matrix you already did. So 0 multiplied by B, it's a minus sign in here, then A multiplied by 0, and you will get the answer in the end 0. Here is the determinant which shows all entries of row 1 are 0. So the answer, you do not go further to solve it. It's by default, answer will be 0. So you write it down accordingly 0. So here's the question 1, and if you want to try to find the determinant, with determinant you also can changing the rows and doing something with operation with the rows as well. Show that this matrix is equal to 0. How we can do this? Let's suppose we are adding second row into the first row. You know the second row. Which is the second row, student? You know that B minus C, C minus A, and A minus B, known as the second row. So which is the first row? First row is A minus B, which I written in here, okay? B minus C, this is known as the first row, and C minus A. What is the question saying? That adding second row into the first row, so we have put in here plus sign. A minus B add with second row, so here the term will be B minus C, okay? This is the second row element, so I put in here. So now this is now the end of the session. So now we are going for this first row element. So as it's saying add second row with the first row, so we already written here the first row, so we will add with second row element, which is line here C minus A. We write in here C minus A, okay? So for the next element, this is our first row element, as it's saying adding second row into the first row, so we write in here first row. Now we are going to add with the second row. The second row element is A minus B, we write in here. So if you observe in here, okay, we have write all the elements in here, and down all the element will be same just because we have only changed the first row, okay? So now furthermore, if you see that minus B in here and plus B are cancelling each other, okay? Now it will become A minus 3, okay? And if you observe in here as well, that minus C and plus C are cancelling each other, same the value will be B minus A, and here A minus A and plus A are cancelling each other as well, and then the remaining term is C minus B. I put this matrix, or we can say determinant, in this way, so we can solve further in easier clean manner. So now they're saying add third row. Now he's saying about the third row, adding third row into the first row, okay? I think student you can do it yourself. I will do definitely. Give me the answer, okay, in your comment section. I want to know who will do it first, because it's very easy. So we know that which is our first row, which is our third row, okay? Same in here, I am written our row first, okay? I am writing all elements, but this is our row first. What we are doing, I am adding, okay, with third row, okay? So I am adding with the third row. So now you know that AC will be adding with the C minus A, okay? You know that this is the third row adding with the first row, okay? So now what is for the second element? Now the B minus A will be added by the third row, so the third row is our minus A minus B. So now adding A minus B in here, because this is the third row adding with first row, okay, accordingly elements position. So now this is our third element of the first row. Now what the question, what is the term saying? This adding third row. So now this is our third row, this is our third row, because it's in here third row plus sign, just because it's saying adding third row into the first row. So we are adding third row with the first row, this is the first row, and accordingly element. So now C minus B. So now what I am doing right in the next slide, I am going to remove this term I am keeping, and the other remaining terms I am removing, okay? So now this is our term. So now if you observe this, these are cancelling each other, because this C is a plus sign and C is a negative sign. Now they both are cancelling, but you observe further, A is in a negative sign and here A is a positive sign. Also they are cancelling each other, okay? So now the value will be 0 surely, and if you observe in here, these four elements are also cancelling each other, okay? So minus B is cancelled with the plus B, and minus A will be cancelled with the plus B, so the answer will be 0 in here as well. So now if you observe again in here, here plus c is cancelling by the minus c, and minus c is cancelling by the plus c, you will get the 0 as well in here. So now here we apply the property number 4, which said that all entries of the row 1, if 0, then the determinant will be the 0. Okay, so hence proved. Student, hope you understand all this. So my dear student, I try my best to make you clear the topic so you all may understand. Okay, so inshallah. So if this video helped you in any way, then hit the like button. Thank you. Take care of yourself.